the second question on the method of differences. It requires us to use partial fractions in order to create our difference, and allows us to look at how we treat fractions during the method of differences. So I've done some work already. I've done the partial fraction work here because that is assumed knowledge from your maths A level. As you can see, we've generated a difference with having a minus sign here. So the sum that I'm going to evaluate can be written like this. I've put in r equals 2 because that's what I'm required to start, 3 and 4. And I'm about to do the fractions for the end of the sum. So I've included n minus 2 this time. So that gives us 1 over n minus 3 minus 1 over n minus 2. And r equals n minus 1. 1 over n minus 2 minus 1 over n minus 1, and r equals n. We've got 1 over n minus 1 minus 1 over n. Now, as I've put over here, do not cancel fractions. It's reasonably easy to spot the pattern in this one, but sometimes if you cancel the fractions down, it's really hard to see what's going on. But in this case, they cancel nicely, and we can join them together by crossing out with a continuous line. That will cancel with one that's missing, ditto that one, continuous line there and there. So you can see that I'm left with this term here and this term at the top. So my overall sum is equal to 1 minus 1 over n. And over a common denominator, we can make that n minus 1. So that gives me my final answer. One thing to note, they've started the sum at r equals 2, because if I sub in here with r equals 1, I obviously generate an undefined term. Right, let's have a look at question 3 at the bottom of the page. It is a harder one. Again, it's partial fractions. Why is it harder? In this case, we have got terms that are non-consecutive. So we've got non-consecutive terms, which makes the spotting of the pattern for the cancellations harder. Okay, and as you can see, we've got 3 fractions, so our cancellations are going to involve putting 3 fractions together. Now, part A is partial fractions, but I am just going to give you the result on that because I want you to focus on the part B and then the part C. So for part A, we get the result that 2 over r plus 1, r plus 2 is equal to 1 over r minus 2 over r plus 1 plus 1 over r plus 2. So as you will see, I do have a minus sign, so I've got a difference, but I've got 3 fractions. So let's have a look at part B in detail. And that's obviously part A being produced by partial fractions. So part B. I'm being asked to come up with the sum from r equals 1 to n of 2 over r plus 1, r plus 2, And I'm going to work with the sum from r equals 1 to n of 1 over r minus 2 over r plus 1 plus 1 over r plus 2. And that's going to equal, and we're going to let r equal 1. So that's 1 over 1 minus 2 over 2 plus 1 over 3. Notice I'm not cancelling down. Plus r equals 2. 1 over 2. 2 over 3. Quarter. R equals 3. 1 over 3 minus 2 over 4 plus 1 over 5. R equals n minus 1. So 1 over n minus 1 minus 2 over n plus 1 over n plus 1. Lastly, r equals n. So 1 over n minus 2 over n plus 1, 1 over n plus 2. Now, looking for the pattern. If more rows are needed, you put them in. But you will see that you're going to look for the fractions with the same denominator, which is why we did not cancel. And look here, the thirds. I've got a 1/3, minus 2/3 plus 1/3. Those three fractions cancel. Difficult to see. Perhaps I need another row. Let's have a think about r equals 4. What would that give me? It would give me 1 over 4 minus 2 over 5 and plus 1 over 6. Look, again, I've got three fractions cancelling. I've got the quarters cancelling. That means the fifths will cancel and so on, and the sixths. And I will get a pattern where this cancels with 2 more rows. And I will get a pattern at the bottom. Look, I've got 3 fractions at the top. I'm going to end up with 3 fractions at the bottom because the 2 over n and the 1 over n will cancel with 1 above, and this one will also cancel. Okay, I have obviously got more terms between my top rows and my bottom rows, but you can now see I've got 3 fractions here and 3 fractions here that do not cancel. So my sum becomes, what have we got here? 1 minus 1 1/2 plus 1 over n plus 2, and then we've got these two together give us minus 1 over n plus 1. And that's my overall result. Okay. Let's now have a think about how I might go on and use that in part C. Part C is asking me to consider a limit. Because it's asking me to consider what goes on when I go all the way up to infinity. So let's have a think about what they're asking me for. They're asking me for the sum between n equals 1 and infinity of my original question, 2 over r, r plus 1, r plus 2. Now we know that equals my answer that I've got for B. So what I'm going to find, because I can't sub infinity in directly, I've got to evaluate it as a limit. So we're going to find the limit as n tends to infinity, my answer from B. So that's a half plus 1 over n plus 2 minus 1 over n plus 1. Let's have a think about what goes on as n tends towards infinity. As n tends to, and this single arrow here tends to is formal maths, infinity. 1 over n plus 1 tends to 0. I've got a mistake there, that's a 2, and 1 over n plus 2 tends to infinity. So that means that my sum, they've asked me for in the question, from m equals 1 to infinity, 2 over r plus 1, r plus 2 equals, those two are naught, so we are left with a half. So my limit, or my sum, if I go all the way to infinity, is equal to a half. We'll come on and look at limits a little bit more when we do improper integrals. But that's method of differences. You can see clearly now why we don't cancel our fractions. You will sometimes have more terms, or you will find that you cancel on more than one row. Maybe sometimes you cancel on the top row, you miss out a row, you go to the next row. There are various different combinations, but what's really important is that you have written your solution nice and clearly coming down the page so that you can clearly see the cancellations. If you look at examples in various other places where they've written them across the page, it's a lot harder to see the cancellations. So I want to see vertical working with non-cancelled fractions, which hopefully will then allow you to see the pattern and come up with the correct algebra.